All right. So check this out. These are rational expressions, which makes this a rational equation, right? Rational just means ratio. It's a fraction, right, Dylan? Yeah? All right. So we need to get x by itself. We're done when we have something. Is that color hard to see?
Yeah.
Oh, let's not use that color. So we're done when we have something that says like x equals some number, right? And there's a bunch of issues with this equation. Like, for example, we have two x's and they're on opposite sides. We got to get them together. And they're both trapped in a group. This is in a group, that's in a group. So we got to get them out of the group. Before, like what we did yesterday, the groups would look like something like this, right? This is what our groups would look like yesterday. And to get them out of the group, we would distribute. Well, here, because, wait, hold on, let me back up. So Allison, we would distribute because this is multiplication, right? If this was something that could be reduced, that would make life really, really easy. Or if this was something that could be reduced, then that would make life easy. But that can't. Huh. So Diego, how are we going to get rid of the 3 and the 2 so that these groups are like, not grouped together? You're right. We're going to multiply both sides by 6. Because what you do to one side, you have to do the same thing to the other side, right? I'm going to multiply both sides by 6. Man, that's a good idea. In fact, it's going to be 6 over 1. 6 over 1. Tristan's like, what? Where'd you get 6? Yeah. Dang, it doesn't matter where I got 6. You could add anything you want. See this equation over here? We could add 902 to both sides if we wanted. You know where I got 902? From nowhere. It's nonsensical, but it's still true. It's correct. Where I got 6, though, 6 is the lowest common multiple of 2 and 3. It's going to reduce. Because you see, 2 goes into 2 one time, of course, and 2 goes into 6 3 times. And so I'm going to multiply 3 times all of this, but I have to be careful. I have to make sure I multiply by the whole thing. So I'm going to get 9x minus 15. Do you see? Jesse, does that make sense? Yeah? Abraham, what's your question?
Why are you multiplying by 3? Yeah.
Why am I multiplying by 3 right here?
Yeah.
Because 6 reduced to 3.
Okay.
Yeah. Mikey, what's your question?
How come you wrote it like you can distribute like when you wrote 2 times 3x minus 5 over there, and there.
I was giving you an example of what we did yesterday. See, this is still in a group. And the reason this is grouped is because it's being multiplied by 2. This is in a group because it's being multiplied by 3. Today, this is in a group because it's being divided by 3. And this is in a group because it's being divided by 2.
Oh, so we couldn't do the distributive property?
Yeah, you can't distribute here. It's division, it's not multiplication.
So for the 6, you just chose a random number that would reduce?
Well, yeah, but it's not completely random. It's the lowest common multiple of 2 and 3.
Oh, okay.
Yeah. It's a good question, Mikey. Yeah. Juliana, you had a question? That was your question? Oh, did you raise your hand a minute ago? Oh, okay. Natalie, we're good? Okay. Now over here we have to reduce. 3 goes into 3 one time, of course, and 3 goes into 6 2 times. I have to make sure I distribute all the way, so that's going to be 8 minus 2x. We good, Brandon?
Yep.
Okay. Yeah.
When you did it by multiplying each side by 6, but you could also do form of the brackets when you do the brackets.
What are you talking about? Oh, multiplying by writing brackets?
Yeah.
Yeah, of course, yeah. You can write multiplication however you want. Yeah. Okay. I have to get these x's together. Remember, that's the one other thing we learned yesterday, too, is if you have multiple of the thing you're trying to solve for, you got to get them together first. So I need to move the smaller one. That's this one, so I'm going to add 2x to both sides. Yeah? 11x minus 15 equals 8. Did I make a mistake, Anna? other than coming to work today? Wow, you said that out loud? I know. Does that make sense? Am I going too fast with that part? Or are you good? Okay. Juliana's good. Alex, you're good. Allison, you're good. Okay. So now it's easy from here, right? It's just subtract and divide. Well, add and divide, right? So 11x equals, is that 23? So x equals 23 over 11. Yeah.
Wait, so it's better, so to get the x on the same side,
Yeah.
before you do like plus additions
You want to get those x's together first. Because otherwise you don't know where you're moving things to. You might move all the things to the side that's not helping you. Because ultimately we want x equals a number, right? So we want to get that x together first. Yes, Parth?
I just want to know, can you solve it without like multiplying both the fractions by a number to make it
Sure. You could.
like how do you do it?
It's going to be very ugly, but let's do it. So I'm going to rewrite the whole thing. 3x minus 5 over 2 equals 4 minus x divided by 3, right? Dang. Would you agree that this thing right here would be the same as you could solve that? Which x is smaller, negative x over 3 or 3x over 2? So you're going to add x over 3. Let's add x over 3. We need to get a common denominator. Let's see, that's going to be 6. So I'm going to multiply by 2 over 2. I'm going to multiply this one by 3 over 3. That's 2x plus 9x over 6 minus 5 over 2 equals 4 over 3. Okay. Right? Do you see how it's going to go? And then you're going to add this, and then, yeah. You get the same answer. This is way easier. I think have I sufficiently convinced you that this is better? Yeah, way better, right? And this is with easy numbers, 2 and 3. Imagine if they were ugly numbers. It would be very difficult. Okay. Who's got homework questions? Whoa, man, we got homework. Do we have homework questions today?